Hello everyone, welcome to today's daily Leetcode challenge. Let's get to question 2870, minimum number of operations to make an array empty. Alright, the description goes that if you are given a zero-indexed array nums consisting of positive integers, there are two types of operations you can apply on the array any number of times. Alright, and those two operations are choose two elements with equal values and delete them from the array, or choose three elements with equal values and delete them from the array. Return the minimum number of operations required to make an array empty, or -1 if it's not possible. So in my own words, we're given this large input array, and there are integers in it that will most likely are repeating over and over. If the integer repeats 3 times, so if we have 1, 1, 1, we can take those 3 ones and remove them entirely from the array. We can do that operation as many times as we want. The other operation that we can do as many times as we want, if there are 2 matching elements, we can take them and remove them. Since we can remove them any number of times, it is basically equivalent of dividing the number of those elements, the number of times those elements appear in the array, by either 2 or 3. Or a combination. We can first divide by 3, and then have some left over, and then if we can see if it divides by 2. Alright, I think we can get to the examples. Let's look at example number 1. The output is 4. Let's see how they got this. 2, 2, 2, 2. There are 4 2's, and we know that we can either choose 2 and remove them, or 3 and remove them. If we choose 3, then there will only be 1 left, and we'll have to return -1. So we don't do that. We choose to remove them by 2's. So we remove the first 2, and then we remove the second 2, and that's already 2 operations. I don't know what happened there, but the other operation is on the 3's. There are 3 3's, so we can use the remove 3 operation to remove them. And finally, the 2 4's. What is going on? Am I pressing something? Very interesting. I don't know what's going on. Why are there balloons? Anyway. Cool. So yeah, the output is 4. For here, the output is -1. Let's see why. Because we have 1, 1, and 1, 1 doesn't fall into any of these operations, so we can't remove all of the elements from the array. Thus, the output is 1. Okay, how do we go about this? Well, we're definitely going to be using the property or the operator module in this case. Module tells us if dividing a numerator by a denominator yields either a complete, either a whole number or some sort of fraction. If it's a fraction, then the remainder is the modulo. For example, 4 modulo 3 is 1. Why? Well, because 3 goes into 4 fully once, and that is 4 minus 3. The remainder is 1. So we can use that to our advantage here. We can have a counter that is implemented as a dictionary of key value pairs, the keys being the numbers themselves and the values being the number of times they appear in nums. Let's have the operations equaling 0 initially, and for val in counter values, we're going to now figure out what logic we have to do here. Well, for 1, I know that if the value is greater than 1, then there must be a solution. Why is that? If the value is 2, then we can use this. If the value is 3, we can use this. If the value is 4, we can use 2 of these. If the value is 5, we can use one of these and one of these, and so on and so on. You get the point that any appearance besides 1 is solvable with these 2 operations. So, however, if val is equal to 1, return -1. This just means that if the value count of some number is 1, then the question is unsolvable. What do we do after? Well, after, we're going to use the property of dividing by a whole number to our advantage. What do I mean here? 3, let's do val divide means divide without a remainder by 3. What will this do? Well, this will add to operations the number of times 3 goes in fully into that number we have right now. So if the number is, hold on, that's a problem, because if it's 4, if the number is 4, then we would, numbers anything but 4. Okay, this could still actually work, because the only exception to this logic here, that val any number divided by val that's greater than 1 divided by 3 gets the ops plus val divided by 3, is the exception to that is 4. Anything above that should be good. Hold on. If val modulo 3 is equal to 1, then ops plus 1. Let me see if this works. Return ops. This portion may be a bit confusing. Okay, so yeah, it works. Let me actually see if it works completely. If it does, then I'll quickly explain what's going on. It does. This is what's happening here. Let's say that you have the number 4. Well, the number 4 is going to be broken down into 2 and 2, right? These 2 operations. Okay, wait. Val ops. The operations here are going to be 1 and 1. Why? Well, because first we're going to take the 2, we can't take the 3, and then we're going to take the 2 again. So we have 2 operations. However, from the point of view of what does val divide by, it does divide by 3 one time fully, and then there's a remainder. The remainder, by the way, is this last 1 here. And if the remainder is 1, that means that we have to actually almost trace back to what we should have done instead, which is not taken the 3 away from the 4, but taken the 2 away from the 4, and there we would have been left with just a 2. And in that case, that extra 2 is just going to be converted into an operation of choosing the 2 element instead of choosing the 3. So 4 divided by 3 integer is 1, and if val is equal to 1, then yeah, that's just a better way of saying divided by 1 or 2, so it doesn't matter. If divided by 1 or 2, then operations plus 1. And if the value is, let's say, 2, then 2 divided by 3 is just going to be 0, and val modulo 3 is going to be 2, and ops plus 1, that's our one operation. So, I mean, this beats everything. There is pretty much no faster way to do it. The numbers, I believe, the constraints are extremely large, so doing this iteratively would not work. So you need to notice this, that you need to use modulos, the property of a even divide versus an uneven divide, and how modulo notices that here. Alright, well, with that, thanks for watching. Please like and subscribe to this channel. I'll see you guys tomorrow. Bye.